Hi, let's discuss 2001 essay mechanics question, which is from fluid dynamics. Okay, I'll read the question. Bernoulli's equation for a fluid flow can be written as P plus half rho V squared plus rho G H equals constant, where all the symbols have their usual meaning. Okay, so the question A, Roman number 1, state the conditions under which the Bernoulli equation is valid. So we know the Bernoulli equation is valid under the following conditions, which are incompressible, which means we cannot compress and change the volume, and non-viscous. There is no viscosity between the fluid layers, and streamline flow. Streamline flow of liquid. So these three are the conditions that we can use Bernoulli equation. Okay, and the Roman number 2, show that the above equation is dimensionally correct. So we want to show that this equation is dimensionally correct. That means the dimension of this term is equals to dimension of this term is equal to dimension of this term. So first I take this term, which is the pressure. So dimension of pressure we know ml minus 1 T minus 2, right? Okay, and now we'll consider the dimension of this term, which is half rho V squared. So that is the dimension of half plus dimension of rho. I can write that as like this. So V squared dimension, and then I can write this further. The dimension of half, it's dimensionless, it's just a number, so it is 1 into the dimension of rho, density. The density has the dimension of ml minus 3. Okay, the mass or volume, so dimension is ml minus 3 into velocity squared. So I can write this v squared dimension, that is actually equal to dimension of v squared, right? We can write that like this, right? So dimension of v is, we know, T minus 1, this term squared, right? So let's simplify this. We get here m, and here L minus 3, here L squared, so we get L minus okay, I write like this, L minus 3 and L squared T minus 2, so we get ml minus 1 T minus 2. And finally we have this rho gh term. Let's see, so dimension of rho times dimension of g times dimension of h. So density has the dimension of ml minus 3, and the gravitational acceleration, which is a acceleration, so dimension is lt minus 2 into a length, dimension of a height. So we get here m L minus 1 T minus 2. So we can see each term has the same dimension, so I can write dimension of P equals dimension of half rho V squared equals dimension of rho GH. So therefore the above equation is dimensionally correct. Okay, and then we have we answered part A, part B. Okay, let me read the question. The insecticide sprayer shown in figure has a pump with a diameter 60 millimeter. Okay, the diameter of the outlet tube, so this is the outlet tube, has tube Q is 2 millimeter, and the insecticide level is 90 millimeter below the tube. So here it is below the tube, it's 90 millimeter, the insecticide level. Okay, insecticide level. Okay, assume that the pressure at A and B is same, so I can write PA equals PB. They have given us to assume like that. Okay, and assume that the pressure is same as that at B and A behave according to all the conditions that you have mentioned in A1. That means incompressible, non-viscous, streamline flow. So better we can write here fluid because it's more general for both liquid and air. Both are fluid. Okay. And now okay, so they have given the conditions and parameters. So under B part 1, what they are asking from us, calculate the minimum speed with which the piston P of the pump should be pushed if the air jet in the tube Q contains insecticide. Now now as we move here, this air flows here, right? As the air flows, what happens? The pressure reduces, right? Pressure reduces. So as the pressure reduces, due to the pressure inside, this liquid, I mean insecticide, will rise from this tube, from this vertical tube. So that depends on how much the speed we are pushing this, right? So we want to find the speed such that this liquid raise about this height, raise to this vertical horizontal column, right? Okay, so we will do the math. For that, first I had consider, now this has to be increased up to this point. Now I consider this point is C, right? Therefore the if liquid raise up to this point, the pressure difference between these 2 points, which is PB minus PC, should be this pressure difference due to this the insecticide raising in this air column, which is H rho. I take here the rho as rho I, which is the density of the insecticide, G. So the pressure difference has to be H rho Ig. Okay, so this is one equation, and then I can consider these 2 points, point A and point C. I can consider these 2 points and I can use Bernoulli equation. So I can write considering point A and point C, considering A and C and applying Bernoulli principle or Bernoulli equation. Okay, so now I can write here pressure, I take it as PA plus, here let's say this piston is moving with the speed of VA, so the air molecule here has speed VA. Now I'm considering Bernoulli equation for this air flowing a streamline from here to here, right? Okay, so if I move this piston with speed VA, so the air molecule here will move with the speed VA. So we actually want to find VA in this problem. Okay, so I can write here PA plus half rho VA squared. Now here the potential energy term doesn't comes because this term doesn't come because both are at the same level. So if you write both sides of the equation, they cancel each other since they are equal. So we can write the equation without that term. equals PC plus half rho VC squared. Okay. And here now we can write the pressure difference PA minus PC. PA minus PC, right, is equals to half rho. I can write VC squared minus, taking this term to the side, half rho VA squared. So PA minus PC equals half rho is common, where rho is the density of the air. So VC squared minus VA squared. Now we can consider, now we can see here the cross-section area is large, here cross-section area is small, so it is obvious that VC is large, right? So that means PA is greater than PC. Okay, so this equation is mathematically correct. Okay, and here now also we can write this by continuity equation. By continuity the rate of volume of a flow of air, which is here, I can write VA times the cross-sectional area at A, let's say AA, is equals VC velocity at C times cross-section area at C, AC. This is by continuity, because if it's moving at a whatever the volume passing this cross-section per given per unit time is equals the same, equal to the volume of air flowing this cross section per unit time. Okay, so from here now we can obtain, and we can subject VC. So VC equals A divided by AC. I subject VC, so A divided by AC times VA, right? Now I can calculate cross-sectional area at A and C, right, because the diameters are given. So first let's do that max here. So I can write VC equals AA. So the diameter is 60 millimeter, so radius is 30 millimeter. So I can write that as phi, because cross-section area we know phi r squared, right? Phi into radius is 30 millimeter squared, right, divided by, so phi r, radius is 30 millimeter squared. Okay, and then diameter at C is 2 millimeter, therefore radius is 1 millimeter. So phi 1 millimeter squared into VA. So we get VC, 5 cancels off, 30 squared is 900, right? Divide millimeter squared divided by 1 millimeter squared into VA, so the units cancels, so VC is equals 900 times VA. So this means whatever the speed here, the speed at this point at this cross section is 900 times the speed here, right? So VC equals 900 times VA. Now we have this relationship, right? From here we have one assumption we can use, which is PA equals PB, so which implies that if we use here PB equals PA, so instead of PB I'm using PA, so PA minus PC equals H rho I G. Okay, so from these two equations I take this as equation 1 and this is equation 2. So from these two, from 1 and 2, from 1 and 2 we can write h rho ig equals half rho vc squared minus va squared. Now we know what is vc here, we can subject that here. So h rho ig equals half rho. Now vc is 900 va, right? I can write down here 900 va squared minus va squared. Okay. Now I can write this, let's simplify, let's substitute all the values here, right? So here h is the height of the this thing, this height, right? This is the h I take consider, which is 90 millimeter, right? Okay, so here I can write this as 90 millimeter, so 90 into millimeter, so we had to write meters, which is SI unit. Now I didn't write here in meters because the units we can see there, it's a ratio, they cancels off, right? But here I have to substitute in SI unit. So 1 millimeter is, we know, 1000 of meter, so 10 to the minus 3 meters. And rho I, density of the insecticide, that is given in the problem. You can see in the Roman number 1, under that they have given take the densities of insecticide and air to be 10 to power 3 kilogram per cubic meter. So the insecticide, so insecticide rho I equals 10 to power 3 kilogram, that means 1000 kilogram. And then the rho value is 2 kilogram. We know it's in kilogram per cubic meter. Okay, I can then put here rho I is 10 to power 3 into the g, gravitation acceleration 10, equals half into rho is 2 into, now here I can write this as va squared is common in these two terms, right? So I can take va squared common out, so here we get 900 squared minus 1 into va squared, right? I take v squared out from these two terms. So let's simplify this. Here 10 to the power minus 3, 10 to the power plus 3 cancels off, half and 2 cancels off, so here 900 equals, now here 900 squared minus 1 into va squared. Now here comes the catch. Now this is, I can take roughly equal to 900 squared because this is a very big number, right? Very big number, 900 squared, right? It's a very big number. Reducing 1 from it, it's negligible, right? So I can assume this is nearly equal to 900 squared. So we can have, so we will have va squared equals, I take this 900 into, because I take this is approximately 900 squared, is equals to, into va squared is equals to 900. So one of this 900 cancels with 900, so we get va squared is equals 1 over 900, right? 1 over 900. So let's simplify this further, right? Then that means taking square root both side. Now what we get is va squared equals 1 over 900. So 900 is 30 squared, so we get va equals 1 over 30, right? 1 over 30. In the units of, we substitute all in SI unit, so we get in ms minus 1, right? So this is roughly VA equals 1 over 30. We know 1 over 3 is 0 0.3. Am I right? Wait, 1 over 30. So 1 over 30 is like, I can have, what is 1 over 30? 1 divided by 3 is 0 0.3333 like that. So dividing by 3 we get 0 0.0, dividing by 10 gives 0 0.0333 dot dot dot, right? So we can have this, we have approximately VA equals 0 0.03 meter per second, right? Or else this is also, I can write as VA equals, I can write taking 2 decimals to the other side, that is 3.3 centimeter per second, right? Okay, either one of these acceptable answer. Okay, because here I take 3.3 because if I take 2 decimals, so after the decimal it's not 0, we have 3, right? Because don't forget this is 0 0.033333. Okay, so be careful with rounding off. Okay, so that's the answer required. So if we push this with such speed 3.3 centimeter per second, is it we are capable of getting this insecticide to this point. Okay, and in this same and then we have one last question, which is under B part, Roman number 2. I'm writing here. Okay, if the net resistive force acting on the piston, if the net resistive force acting on the piston of the pump is 20 Newton. So resistive force means it's opposing the direction of motion, right? So here we have resistive force 20 Newton, right? 20 Newton. Determine the force that has to be applied on the piston in order to maintain the speed calculated above, right? So it says in order to maintain the speed calculated above, so we have to maintain the same speed. That means we have to move this with a constant, so we can say VA constant, right? So according to Newton's first law, if an object moving with a constant speed means the forces has to be balanced. Therefore the force that we have to apply on this piston is it should be 20 Newton. So the forces are balanced, so this one will move with the same speed. So that's all. Yeah, so I hope the discussion was clear. Take care.